In the dead of night, Ukraine's air force was jolted awake as Russian attacks primarily targeted the country's gas extraction industry. A total of 67 missiles were launched, including 43 cruise missiles, 3 Kalibr ballistic missiles, and 8 Kh-59 or Kh-69 missiles, along with 194 drones. The assault followed a sequence. The slower drone like Shaheed came first, followed by the faster Lancet drones. Then came the cruise missiles and finally the ballistic missiles. These are perfectly timed so that they more or less reach at the same time to create chaos. For the first time, Ukraine deployed French Mirage warplanes to help fend off the attack, according to the Air Force. The Mirage 2000 is a highly agile, multi-role, single-engine jet with a distinctive delta-wing design, making it a formidable fourth-generation fighter. They also used these Western-supplied F-16 fighter jets in its arsenal to intercept Russian missiles. In total, Ukrainian air defenses and fighter jets shot down around 34 missiles and 100 drones, the Air Force reported. Meanwhile, up to 10 missiles failed to reach their targets and 86 drones vanished from radar, likely jammed by electronic warfare. To counter Shaheed drones, they used Soviet-era helicopters, and then soldiers used machine gun to take them down. This is how an onboard gunner shoots from a helicopter and takes down a Russian Shaheed drone. When the helicopter and the Shaheed drone were at a similar speed, a turret gunner, using a Mag 7.62mm machine gun, started firing in its direction. This short burst of fire at its engine put it out of the sky. This is how Russia is using these Orlan drones capable of penetrating up to 600 kilometers into Ukrainian territory. The second type of drones are FPV, guided by fiber optic cables. These have a range of only 1 kilometer or about 1.2 miles. Standard FPV or first-person view drones, on the other hand, have a range of 10 kilometers or roughly 5 miles and more. Next are the Lancet drones. These are advanced main battle tank killers capable of flying for 40 kilometers or about 24 miles. Finally, there are the Iranian Shaheed drones, which can travel up to 1,000 kilometers or approximately 620 miles. These drones can cause significant damage when launched in large numbers. More details all in the video ahead. In the era of drone warfare, Russia's strategy unfolds through a series of coordinated stages, each designed to maximize the effectiveness of their aerial assets. Stage 1. Surveillance and target acquisition. The first stage involves the use of Orlan drones for surveillance. These drones are critical in scanning the battlefield for Ukrainian targets, serving as the tip of the spear in the process of identifying and selection. Stage 2. Precision strikes with Lancet drones. Once targets, such as Ukrainian tanks or Gepard anti-aircraft guns, are identified, the next step is to launch Lancet drones. These drones are deployed to destroy or severely damage the identified targets with precision. Before we examine how it works, let's look at its parts. Although the Lancet can be operated by a two-man crew, but behind the scene it has a number of parts that helps it to operate in the battlefield. Number 1. It requires a catapult to launch a drone. Number 2. An Orlan drone that is responsible for navigation and observation for the Lancet. Number 3. A command and control center is required to operate the Orlan as well as the Lancet drone. As data regarding the Lancet drone are still classified, let's take a look at the parts as a possible theory. Again, I repeat, this is a possible theory of the engineering behind the drone. At the front of the drone is the electro-optical guidance systems. These cameras act as a light contrasting edge of the target, dark or light, against the general background to track and guide itself. In short, it acts as a guidance mechanism. Just behind the guidance system is the warhead. It is the typical KZ-6, a high-explosive circular-shaped charge used for demolition, primarily to penetrate armor and reinforced concrete fortifications. Moving to the back is the electric-powered engine that propels the drone to the standard speed of 110 kilometers per hour or 68 miles per hour. Interestingly, this drone can operate only for 40 minutes, almost similar to the Switchblade 600. These are the step-by-step process of how this works. Step number 1. 2 soldiers launch a surveillance drone named Orlan using a catapult system. Step number 2. The Orlan drone tracks and selects targets. Step number 3. A soldier unfolds the Lancet drone wings and sets it up for catapult launch. Step number 4. The Orlan command and control system transferred data target to the Lancet drone. Step number 5. The Lancet drone switches to its electro-optical guidance systems as directed by the Orlan command and control center. Step number 6. The Lancet drone will dive into the target and activate the typical KZ-6, a high-explosive circular shaped charge used for demolition, primarily to penetrate armor and reinforced concrete fortifications. Let's simplify again through these animations. The Orlan command and control system transfers target data to the Lancet drone. The Lancet switches to its electro-optical guidance systems to track its target. It then descends upon the target using its KZ explosives to penetrate light armor, artillery, guns, or trucks. Stage 3. Saturation attacks with Shaheed drones. In the third stage, Russia employs low-cost Iranian Shaheed drones, which are launched in large numbers, sometimes up to 200 at a time. The affordability of these drones allows for mass deployment, overwhelming Ukrainian defenses, and increasing the likelihood of successful strikes. The sheer volume of Shaheed drones in the air serves to saturate the battlefield, making it difficult for Ukrainian forces to counter all of them. While this drone has a different name in Russia, and it's called Jolted 2. While the Islamic Republic of Iran unofficial name is Shaheed 136. There are slight differences and upgrades between the two. The Iranian Shaheed 136 uses an inertial navigation system which cannot be jammed by radio frequency interference. However, it has its disadvantages. Its real-time position data is less reliable than that of GPS. Once released, it is difficult to track or command. The Russians upgraded these drones with GLONASS, a Russian alternative to GPS. The advantage of this upgrade is that the drone can loiter and hit its targets when GLONASS or GPS data is linked in real time. However, the disadvantage is that it can be jammed by bombarding it with radio frequency interference, which could cause the drone to crash. The reason they are using these drones is because of the cost factor. This Russian cruise missile cost $1 million. The American cruise missile costs about $2 million, while the Shaheed 136 is essentially a low-budget cruise missile with a reported price tag of just $10,000 to $30,000, depending on the variant. To put that in perspective, the average price of a car in America is around $40,000. The drone is carried on a simple truck carrier that looks like it is carrying cargo. In this standard truck, they can carry as much as 5 drones stacked against each other. At a press of a button, the drone is launched with a rocket-assisted takeoff. This rocket-assisted takeoff is ejected just like this visualization here. This was installed to reduce weight and efficiency and let the 2-stroke engine take over. Stage 4. Support from civilian drones. Accompanying the more sophisticated drones, civilian models such as Mavic 3 drones are utilized in the 4th stage. These drones provide additional reconnaissance and support, offering real-time situational awareness and aiding in the coordination of strikes. This allows for Stage 5, where high-impact strikes with cruise missiles takes place. The final stage of Russia's strategy involves the launch of cruise missiles. These missiles can be launched from the Tu-Pole of Tu-95, Tu-160, or Tu-22. But just a reminder, these high-value aircrafts will not move deep into Ukraine due to the presence of Ukrainian fighters jets like the F-16 and Soviet-era fighter jets. These high-impact weapons are used to deliver devastating blows to strategic targets, often as a follow-up to drone attacks. These aircrafts will launch these cruise missiles from a safe distance and return back to Russia. The precision and power of these missiles ensure that key objectives are destroyed, effectively rounding out the multi-layered approach of Russia's drone warfare strategy. We also make original engineering content, so please subscribe and hit the notification bell for more videos.